Hi, Honors Chemistry. I'm going over 15B now, just an outline. Like I said, I put up some really good videos, so hopefully you can understand those. But I just want to do a little outline of what's in the book so you can see. Maybe I'll explain it in a way that's easier for you to understand or something like that. First of all, it talks about the Haber process. Just read through that section. Le Chatelier's principle, when they figured it out, opened up a way for them to be able to make ammonia because they found that if they did it under high pressure, it would produce enough ammonia. So just read through that whole thing. It also has some moral dilemmas because gas was produced to use in the wars and things. So just read through that whole section on the Haber process. The next thing is the solubility product constant. It's very, very similar to the equilibrium constant because basically it's the equilibrium of a saturated solution. Okay, when you put a whole bunch of salt in water and stir it up, it becomes saturated. And there might be some on the bottom because no more can come up, which is another reason why you wouldn't put the solid in there because what's in equilibrium is the saturated solution. So the solubility product constant, first of all, the solubilities, which is the numbers you plug into these constants to make these constants, must be in moles per liter. In a lot of textbooks they already are, but in this textbook it chose not to give it to you in moles per liter, but gave it to you in grams per liter. So in your chapter review, or if you see that it's given in grams per liter, you can change it to moles per liter simply by dividing by the molar mass of that ionic compound, which I believe they give in that chart in your book anyway. So these are what you're going to plug into the solubility product constant equation to find the solubility product constant. The larger that solubility product constant is, the more soluble it is. And I'll show you why when I write one. And it doesn't precipitate unless you get over that KSP because the solubility product constant tells you when it's in equilibrium. And if something makes it change, it will shift over to the solid side of that equation and make more precipitate. So it doesn't precipitate until that's exceeded. So if you add concentration of the ions, it'll shift it in a different direction. Okay, how do we write it? Well, you say, well, I have no equation. How am I going to write it? Well, you do have an equation because what happens when you dissolve ionic substances? They split into their individual ions. So you write the equation first. That is a reversible reaction. You can just do a single line with two arrows. And notice you have 3 lead ions. So 3 Pb 2 plus. And how do I know it's 2 plus? Because crisscross, that's a 2, that's a 3. Okay? Plus 2 phosphate PO4, and that's -3. Okay? So that's your equation now. And now you write this exactly the same way you did the other. Don't forget, this is a solid. These are in a solution, so they are called aqueous. Aqueous is when it's dissolved in a solution. Gas and aqueous are the only two things you ever put in your equilibrium expressions. Okay, so think gaseous. So my KSP, solubility product constant, is Pb2 plus cubed. Notice you don't ever put those numbers in there. You don't put the coefficients in with it. PO4 -3 squared. And there is no denominator because you don't put the solid in there. So that's your solubility product expression. Now, if you're plugging in your solubilities to find it, then you would do, there's 3 PBs, so this is where you would use your 3x cubed, and there's 2 phosphates, so you do 2x squared, and that would be the solubility. That's where you plug in the solubility of this, because when you have 1 mole of lead phosphate, you have 3 moles of just lead ions. When you have 1 mole of lead phosphate, you have 2 moles. So your X represents your solubility. Okay? Let's look at this one. If I write this, I get calcium and sulfate. And notice there's only 1 of each. And this is a solid. So you'd write the KSP expression of this would simply be so when you plug in your solubilities into there, this would be X and this would be X. So in other words, it would be X squared. So you would be able to solve for your solubility product constant by plugging in the solubilities that you get when you fix it and turn it into moles per liter. Now, if they want you to see if something, solve for one of these, then find the KSP and do this and plug in what they give you for 1 and solve for X. You're only solving for X. Everything will be in terms of X. So if you're looking for the solubilities, use the solubility product constant and this equation to solve it. So you would plug in the number there and then equals X squared and then just solve for X. And that would give you your solubilities. Okay? Now, let's look here. If you might have something called the common ion effect. If I were to add something like calcium nitrate, okay? Nitrate doesn't appear in this at all, and nitrate is always soluble, okay? So it would add calcium ions. Now think back to Le Chatelier's principle. If I add calcium ions, then which way is my equilibrium going to go? It's going to go this way and cause a precipitate. So more is going to precipitate. It is also going to cause this number to exceed KSP. And when it exceeds KSP, that tells you that it precipitates. So when you are given 2 chemicals and they have a always soluble part to them, for example, nitrates are always soluble, all the alkali metals are always soluble, so they don't have KSPs because they're always soluble. Okay, but if you have, say, sodium sulfate, and then so sodium's always soluble, sulfate might not always be, and then you have something like lead nitrate, that will be soluble because the nitrate's soluble, but when the lead hits the sulfate, it will form a precipitate because those two, if you figure out, I didn't put lead sulfate, but let's say it was lead phosphate, okay? Say I had sodium phosphate instead of sodium sulfate. If I take those two and I figure out what the X's are for each of those and put them together, and this number comes out bigger than the KSP for lead phosphate, then you definitely will have a precipitate. And I do those when I do some of the homework problems. So hopefully you can get that. If you don't, then just text me. Remember, text me and I will get back to you as soon as I can. I'm home now. I can answer questions a lot quicker.